Hello everyone. Today we're going to talk about lines and transversals. So, a line that intersects two or more coplanar lines at two different points is called a transversal. Now keep in mind, folks, for any two lines, there's exactly one plane that goes through them. So even if it doesn't look like they're in the same plane, we can probably find a plane they are going to fit through. So in the figure below, line T is a transversal. Two lines of transversal form 8 different angles. Some pairs of the angles will have special names. So first off, I'm going to do some color coding here to help you out. In blue, I'm going to mark areas that are known as exterior. And in yellow, or rather orange, I'm going to mark the areas that are considered interior. Such that these are exterior here because they're outside of this parallel line. Outside of this line. These are outside exterior as well because they're outside of line N. But these are called interior because they are between the two lines M and N. So let's take a look at some terminology. So we have basically 4 interior angles which lie in the region between the lines. In this case, those are going to be angles 4, angle 3, angle 5, forgot my symbol there, angle 5, and angle 6. We're also going to have 4 exterior angles that lie in the regions outside the lines. So these are going to be the other 4 angles, also known as angle 1, angle 2, angle 7, and angle 8. We're also going to have what are known as same side interior angles. Just going to abbreviate interior angles, which are interior angles that lie on the same side of the transversal. Transversal, again, being the line that's cutting through these other lines. These angles are also known as consecutive interior angles. So in this case, our same side interior angles would be angle 4 with angle 5, and angle 3 with angle 6. In addition to our same side interior angles, we're also going to have alternate interior angles, which are going to be non-adjacent interior angles that lie on opposite sides of the transversal. So that would be angle 4, angle 4 with angle 6, as well as angle 3 with angle 5. We also have alternative exterior angles, non-adjacent exterior angles that lie on opposite sides of the transversal. So these will be angle 1 and angle 7, as well as angle 2 with angle 8. And finally, we have what are known as the corresponding angles, that lie on the same side of the transversal and on the same side of the lines that the transversal intersects. The angles share a common same location. So these are going to be angle 1 with angle 5, along with angle 2 and angle 6. So now we want to mark each pair of corresponding angles with the same color. So keep in mind our previous definitions from before. Let's see. Let's go with green for consistency. A bigger dot. My fill function won't work properly here because these lines aren't bounded. It doesn't want to fill up the whole page. Functionally, angle 2 here corresponds with angle 6 down here. Angle 1 corresponds with angle 5 down here. Angle 7 corresponds with angle 3 up there. And angle 8 corresponds with angle 4. Number 2, we want to mark each pair of same side interior angles with the same color. So same side interior, we're looking for the same side of the transversal and interior angles. So that's going to be our 6 and our 4, as well as our 3 and our 5. Number 3, mark each pair of alternate interior angles with the same color. So alternative interior angles, remember they are going to be inside the two lines while also being on opposite sides of the transversal. So we're going to have 4 and 5, as well as 3 and 6. Finally, we want to mark each pair of alternate exterior angles with the same color. So alternate exterior angles, they're going to be on opposite sides of the transversal, and they're going to be outside of the lines that are being intersected. So that's going to be 1 and 8, as well as 7 and 3 are going to make up our alternate exterior angles. Lastly, we have some postulates. Now, I've got some good news for the most part here, because most of these terms are all going to be the same. Corresponding angles conjecture. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. Alternate interior angles. If two parallel lines are cut by a transversal, then alternate interior angles are going to be congruent. Alternate exterior angles conjecture. If two parallel lines are cut by a transversal, then alternate exterior angles are going to be congruent. If two parallel lines are cut by a transversal, for the parallel lines conjecture, they're going to be congruent. Alternative interior angles are going to be congruent, and alternative exterior angles are going to be congruent. So they will all be congruent. Now, in geometry, folks, we use these little arrows here to indicate parallel lines. So this line is parallel to that one, this line is parallel to that one, and this line is parallel to that one, as denoted by these symbols. Functionally, if we have the same kind of symbols and the same amount of those symbols on a line, it's going to be parallel to any line that is going to have those same symbols and amount on them. All right. Converse of parallel lines conjecture. So remember, folks, converses, going back to our conditional statements, are when we had the hypothesis and conclusion switched. So in this case, if two lines cut by transversal form congruent corresponding angles, congruent alternate interior angles, or congruent alternate exterior angles, then those lines, by the converse of our previous conjecture, must be parallel. And finally, our same side angles conjecture. If two parallel lines are cut by a transversal, then the same side interior angles must be supplementary. If you recall, supplementary means that they equal 180 degrees. All right, so that's our notes for today. On Monday, we're going to have some assignments on this, but please, folks, ask any questions about anything you might have difficulty with. Take care. Enjoy the weekend.